Let's have a look at this mechanism. We've got an NH2 going into an NHCOCH3. So an NH2 has got lone pairs of electrons on it. What could it possibly attack? COCH3. Well, the COCH3 has been acyl chloride. It's had a Cl on there. So the NH2 with the lone pair has attacked a COCH3. And the COCH3 on the C, there's been a Cl. It's been CH3COCl. It's been an acyl chloride. Let's have a look at the mechanism then. So what's actually happened is this benzene ring, which I've drawn as C6H5, but you could draw it as a benzene ring, no problem. NH2, lone pairs of electrons on the N, attacks the carbon of the acyl chloride. So I've got CH3COCl, and that's COCH3, so the COCH3 is going to bond to the N in a minute. So the N, with its lone pairs of electrons, bonds to the C. The first step isn't that the Cl comes off, the first step is that the double bond breaks onto the O. I sometimes say, jokingly, that O is like a loan shark. It helps out, but then it comes back and wants to reform the double bond the very next day. So it takes the double bond and it takes the electrons onto itself from the double bond, and there they are here. It forms a minus charge because electrons are moving onto the O. The N becomes plus because electrons are going away from the N. So you can see the N has now got a plus, and the O that's had electrons moved onto it has got a minus. The electrons, the pair of electrons in the bond, are now on the O. And now, just like a loan shark does, it says, I'll help out, but now it wants to be repaid. So the lone pairs of electrons come back into the double bond, so that's reformed, and then that carbon's going to have too many bonds. So now the Cl breaks off, so the electrons from the bond go into the Cl, and to eliminate the N plus, one of the hydrogens breaks its bond and move the electrons onto the N plus. So what you end up with is CH3CO double bond reforming. The C has lost the Cl has gone from here, but the N is still joined on, the N is here, one of the H's is here, the other one's broken off, there's an NH, and then there's the benzene ring here. You've got an amide here. Name of the mechanism, well, everything's added on to make one species here, and then atoms and groups are eliminated. So it's addition followed by elimination. We've got some recrystallization going on here. Why is the minimum quantity of hot water used? So the minimum quantity of hot water is used so that when you cool it back down again, so the idea is that you use hot water or a hot solvent so that the crystals that you want dissolve and the impurities don't dissolve. Then you filter off the impurities and you end up with the crystals that you do want in the water. And the reason that it's hot water is that when you cool them, less crystals can dissolve and they'll come out of solution. But if you use too much water, they'll never come back out of solution despite cooling. The flask was left to cool before the crystals were filtered off, so if you cool it, then the crystals are reformed, and the colder you make it, the more crystals are formed. If you don't leave it to cool, if you leave it hot, then no crystals will form at all. So you make it cool so the crystals reform, and you get a high yield of the crystals when the solution is cool. The crystals were compressed in the funnel so that the air passes through the sample and not just round it. So if you're using reduced pressure filtration or vacuum filtration, then it's sucking the air down through the filter paper and through the crystals, and you want the air to pass through the sample and not just around the outsides of the filter paper. A little cold water was poured through the crystals just to wash away any impurities. There'll be soluble impurities. They've got to be soluble to dissolve in the cold water that's washing them away. The melting point of the sample was found to be slightly lower than that in data book value. State the most likely impurity, well, ore was the most likely impurity is water, and the way that you get rid of it is press the sample of crystals between filter papers. That's always going to be the easiest way to get rid of the main impurity, which is water.